What's up guys, this is Masi, welcome to my channel. In this video I want to talk about the basics of equilibrium system or equilibrium reaction. So I started with an example. When doing stoichiometry calculations, we generally assume that chemical reactions proceed until one of the reactants runs out. So it means that all the reactants consumed completely and there is no reactant left at the end of the reaction. But so at this point we say that the reaction has gone completion. This is true for most of the chemical reactions. However, there are some other chemical reactions that do not proceed to completion. It means that the conversion is not going to be 100%. So in the next slide, I will show you the changes that take place when nitrogen dioxide gas, which is NO2, is placed in a sealed evacuated chamber at 25 degrees Celsius, and nitrogen dioxide gas reacts to form dinitrogen tetroxide gas, which is N2O4. And as you see here in this chemical reaction, it's going to be 2NO2 gives N2O4. So you can see it here. Initially, the vial contains only molecules of brown nitrogen dioxide gas. And in B, some of the nitrogen dioxide gas has been converted to dinitrogen tetroxide gas, which is colorless. And eventually in C and D, equilibrium established, the gas remained the same color. So the sealed chamber ensures that the reaction takes place in a closed chemical reaction system. In a closed system, energy may transfer from the surrounding to the system or from the chemical system to the surrounding, but matter cannot. So nitrogen dioxide is a dark brown gas, whereas dinitrogen tetroxide gas is colorless. So the color in the chamber provides visual effect of their relative quantities. The initial dark brown color of the gas decreases in intensity as it is converted to colorless dinitrogen tetroxide. But at the end of the reaction, there is no colorless material. So we have some dark brown color, but with less intensity. So it means that the reaction is not gone to completion. So it is not irreversible reaction, but we have reversible reaction and we reach to the equilibrium condition. So it means that at equilibrium condition we still have some NO2. So even over a long period of time, the intensity of the brown color eventually remains constant and the gas never becomes completely colorless. And this indicates that the concentration of nitrogen dioxide is no longer changing and the reaction has clearly stopped short of completion. And we can say when the concentrations of all reactants and products of a chemical reaction remain constant over time, we say that this system has reached chemical equilibrium. So whenever we are talking about chemical equilibrium, it means that we have constant concentration for all reactants and products. It means that at this point, the concentration of reactants and products are not changing and the reaction will still going, but you don't notice any kind of changes in the concentration or color, stuff like that. So that's called equilibrium, the difference between equilibrium system and other systems that are irreversible. In irreversible reactions, the reactant is consumed completely, but in equilibrium systems, we still have some of the reactants at the end of the reaction, which is equilibrium condition. So that's basically the difference between irreversible and reversible reaction.